Hare Krishna Krishna Hare 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 Ram 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 Hare Hare. Hello, good evening everyone. Vaishali. Is my voice audible? Please confirm. We have Khyati. Yash Singh. Aditi. Okay, thank you for confirming, Hiransh. Good evening, Ujjwal. Okay, thank you. Thank you, Vaishali. Okay, so we are gathering for this a basic session for specifically CAT 2025. Aditi, I guess, is attempting CAT this year also. You are planning, you are pre-planning for CAT 25 as well. So, any of you are going to attempt this year CAT also? Please confirm. Yes or no? Are you going to write CAT 24 or CAT 25? Please write in comments. Okay, Preeti is writing CAT 24. Astha also 24, Vaibhav. Yash Singh 25, Vaibhav. Yes means what, Vaibhav? 24 or 25? Swapnil 24, Vaishali 24. 24. Most of you are writing 24. In between, few are from 25 as well. Walter, Jesse 25, Vaishnavi 24. What's that, oh my Ben? Yes, not. Hariom 25. Okay, good. Yashasvi also writing for 25, Khyati for 25, Amigo for 24, Neetu 25. Nice. So you have enough mix here. Fine. See, it is certainly helpful for both the students whether you are going for CAT 24 or you are aiming for 25. So this is just a basic session and we are going to discuss few things about numbers. Okay, because numbers is an essential part in all the topics of our quant. Okay, so this is basic quant. That is a theme today, basic series, and we are going to discuss this basic quants. So in this quant part, numbers are an integral part, be it any topic of your quant, be it algebra or geometry, arithmetic, modern mathematics, or numbers itself. So everywhere we are to deal with numbers. Yes or no? Of course, yes. And in your other sections like LRDI, logical reasoning and data interpretation also, we need to deal with lot of numbers and lot of calculations. So everywhere this numbers is an integral part, important part. So today we are going to discuss some basic properties, basic varieties of numbers and few basic concepts. Fine. So let's start now. That's what I mentioned, amigo. So we are going to discuss certainly important things regarding numbers, and you are free to communicate through this medium of chat. Fine. If you have any doubt, any discussion, anything you want to ask, you can certainly communicate through this medium of chat. So I will be constantly looking at this chat also. Okay, so let's start. As you can see on the screen, these are basic operation and bodmas rule. You know, when we are discussing about numbers, so with numbers we need to work with the basic mathematical operations. What are the basic mathematical operations? It says basic operations. What are those basic mathematical operations? Can you mention in the comments? Can you mention in the chat, please? What are the few basic mathematical operations which we can use between any two numbers? If you are having any two numbers, so what different mathematical operations can be performed? And then we are going to discuss about this bodmas and its application also. Zainab, the best books for this CAT preparation is our iQuanta book. So let me show you. You will get a bundle like this, right? Bundle like this, iQuanta books, and these are the type of books. So these are the best books presently available in the market, the latest ones. So if you wish to pursue any book, so certainly go for these books. Fine. And it's not that because you are right now on the iQuanta platform, that's why I'm suggesting that, because these are the latest ones. These are the latest ones. In the market, you will find Sharma, Verma, and many other books. So, but these are the latest ones. So that's why if you wish to continue, if you want to pursue any books, certainly go for these books. Okay. So addition, subtraction, multiplication, division. Fine. So addition, subtraction, multiplication, division. So these are the basic mathematical operations. Other than that, also there are many mathematical operations which we can perform. Anything else other than this? Yashasvi, you can contact our iQuanta team for that. There are various course options available. Fine. So they will help you out. Aditya, even 2-3 months preparation is sufficient if you put your 100% effort. Otherwise, you can find students who are preparing for last 2 years since are unable to do something miraculous. So it depends only upon you. These books are available from our iQuanta team only. So you can contact. Sakshi, your math is very bad. This is the first point. This acknowledgement that you accept that your math is very bad. This is the first step of improvement. You know, most of the people who do not improve, those people who do not know that I need to improve, I am bad at something. So the moment I get to know that I'm bad at something, your improvement has started. And believe me, it is improvable. It is improvable. We have seen a lot of students. I've been teaching for almost 20 years now. And I have seen a lot of students with the drastic change, dramatic change, and very soon, very fast. It just requires sincere practice, continuous practice. Okay? And no problem, Hiransh, no problem. Okay, I'm waiting for your more answers. Any other operations, any other mathematical operations other than these four? Other than these four? Khyati ji, what did you say? Let me see. Khyati, add, subtract, divide, multiplication, that I have seen. Fine. Akash, why to choose iQuanta over another institute? This is not a counseling session, but anyway, it's said that खाने का स्वाद तो taste करने में है ना. The taste is in the pudding itself. So taste it, and then you will give your testimony yourself. Insight grid is saying -3 into -4. See, when you multiply two negative numbers, the result is positive. So -3 when it is multiplied with -4, answer will be +12. Ratios, log, root, that's good. That's good. So other than these, we can use root also. Sometimes logarithm is also an option. Sometimes exponents. Exponents is also an option. Parentheses or brackets can also be used. So these are some of the basic mathematical operations, right? Mostly we use this plus, minus, multiplication, division only. So but the root, exponents, taking logarithm using brackets, that is also possible. Fine. So before we start moving, my major objective is to create that interest in this subject. Fine. So because if I'm able to generate a little interest in the subject, then other thing is very easy. Then rest part is very easy. You will do it on your own. Okay. So let me start. So highest squares and cubes are covered, Vaishali. In exponents, when I'm saying exponent means powers. So it can be any powers, whether it is square or cube or any higher powers also. So everything will be covered there. Okay, so before I move further, now it is a game. The game is, your target is to make 6. Okay, ready for this game? So the game is make 6, that you have to make 6 by using any of the mathematical operations. I'm going to give you some numbers. Fine, I'm going to give you some numbers, and using those numbers along with any of the mathematical operations, you need to make 6. Is it okay? Ready? I'm waiting for your comments. Yes or no? Is it clear? -4 is not bigger inside grid. -4 is smaller than -3. See on the number line. By the way, when we are multiplying, we don't need to see which is bigger, which is smaller. Okay, right. So the first question here, I'm giving you 3 numbers: 2, 1 more 2, and 1 more 2. Your target is to make 6. Write in the comments fast. Write the complete expression, amigo. Yes, wonderful. It's Hiransh. So Hiransh, well played. आप जीतते हैं 1000. Okay. So that's the correct answer. And that was the easy one. So 2 plus 2 plus 2. Any other way, by the way? Any other way? Oh yes, good. Yash Singh and Hiransh. There's another way also. Nice. So we could have used it like this: 2 multiply with 2 plus 2 also, isn't it? So there could be many ways. Excellent, excellent. Let's move to the next one now. Second question. Our target is same. We need to make 6. Again, I'm giving you 3 numbers, and this time the 3 numbers are 3, 3, 3. Answer fast. Okay, I can see many different answers also in comments. Nice. Okay, so for this 3-1, Vaishali is the first one. Good. Yash Singh, Hiransh. Excellent. Excellent. Many of you, I cannot read all the names. It's moving so fast. Aditi Singh, Sania Bhutra, Astha, P. Verma, and Preetam, Vaishnavi, Priyanshu, Swapnil, Riddhi, nothing. Vaibhav Shukla. Excellent. Excellent. So that's correct answer. So it's simple. 3 multiplied with 3 is 9. And 9 minus 3 would give you 6. Nice. Okay. Let's move quickly. I'm sure you have already estimated the next one. So next I'm giving you 3 4s. Again, I'm giving you 3 numbers. This time all the 3 numbers are 4. Please answer now. Himalayan, I do not see the shorts or movies. Rarely in last, I think, last 5-10 years, hardly I would have seen. I would have seen 1 or 2 movies. Waiting for your answers. Sakshi, you are to use the 3 numbers. Excellent. I got my first answer here. Vaishali. Good. Excellent. P. Verma has a different answer. Nice. Excellent. I'm putting it here. So the first answer was given by Vaishali. Vaishali says we can use square root here. So square root of 4 is 2 and again 2 and again 2. So it is 2 plus 2 plus 2. That is 6. That's perfectly nice. And we have this P. Verma. So Mr. P. Verma says that 4 plus 4 is 8 minus square root of 4. That is 8 minus 2. That is also 6. Very nice. Good. Excellent. Amigo has another wonderful solution. Amigo says 4 plus, but Amigo, we cannot use any other number. Amigo, you have used extra 2. We can't use that. Sanat, that's nice solution. Sanat and AN, yes, they are saying same thing. Let me write that. So what they are saying is, this 4 is divided by root of 4, which makes it 4 divided by 2, that is 2, and 2 plus 4, that would be 6. Excellent. Excellent. Wonderful. So nice thinking. So that is the whole objective of this small exercise, that there can be various ways to find our answer. Fine. There can be various ways to solve a question. There can be various ways to solve a question. It's not that I need to do through this method only, this method only. There can be various methods. Point is that you must use your intelligence. You must work for it. And if you will think, you will start thinking, certainly you are going to find some ways. So you will be doing some steps correctly, some steps may be wrong, and then you will get to know that what is correct and what is not. ठीक है ना? So that is the whole objective. Okay, before we end this exercise, just let's do one more part, the fourth one. This time I'm giving you 3 numbers and each number is 5. Can you make 6 now? Our target is same. We have to make 6. Excellent, amigo. This time it is on point. Good. Nice. Aman, Raj, Vaishali. Vaishali ji, 1 kahan se aaya? I think you mistyped. Yes, that's correct answer. Most of you are writing that. That's nice. So it is simply what we can do is 5 is already there. So we need one to be added. And for that purpose, we can divide 2 5s. So let's say 5 divided by 5, that makes it 1. And 1 plus 5, that would be 6. So most of you are writing the same thing only. Good. Excellent. I hope you can easily continue this with the further numbers as well. Anyway, so we shall stop it here. Let's move further. Any doubt so far? Is it clear? See, there are many number games which come in many of the newspapers, and there are many apps nowadays also. So number games certainly are very helpful in developing our familiarity and our liking toward the numbers and calculations. So this is one such number game we have just played. There are many other number games. Sudoku is one good exercise regarding developing this logical thinking. So I highly recommend playing this Sudoku regularly. Amigo, these different types of brackets are just brackets only. So normally if all the brackets are being used together, in that case we follow a particular order in which they are to be used. Thank you. So now you brought me to the next part, that is the use of bodmas. What is this bodmas? So we are going to discuss about that. So I hope this is clear. So play number games, and regarding number games, this is one. Sudoku is very important number game, and I'm sure many of you must be familiar with this Sudoku also. There are various kinds of Sudoku available nowadays, and again in newspapers also you find various Sudokus, and beside that there are many websites or mobile apps also which have this game. Okay, so let's move to this bodmas. Can any of you tell me in the comments what do you mean by bodmas? What is the meaning of this bodmas? I'm erasing all these things from screen. Yes, please. What this bodmas about? Yes, it is bracket of division, multiplication, addition, subtraction. Thank you, Hiransh. So basically, this bodmas rule, it is the rule of applying these operations, in which order we need to apply these various mathematical operations. So this bodmas here, S talks about subtraction, that is negative. A talks about addition. M talks about multiplication. D for division. So most of the times we are using these basic operations only, and sometimes we need to use the other ones also. O refers to off. So off also basically means multiplication only, but this off is used prior to multiplication sign. Fine. So although we do not get any typical questions based on this, but anyhow this is the order we are to follow. And this B refers to brackets, and as Amigo mentioned, there are various kinds of brackets. So normally we have these three specifically. So this sometimes we call it round brackets or small brackets, then curly brackets, or sometimes we call it medium bracket, and then we have square brackets. Fine. So they are solved in this operation only. First we solve the whatever content is there between these two round brackets, then this curly ones, and then the square one. So this is the order of operation. ठीक है ना? And beside that, somehow there is one more type of bracket which is known as bar, and which is called vinculum. So sometime bodmas से पहले we introduce one more, we insert one more letter here, V, which V refers to vinculum. This vinculum is nothing but bar, and this bar is also sort of bracket only. So सबसे पहले we will use this, we will solve this vinculum. After that, this small brackets or round brackets, then curly brackets, then large brackets, then off, then division, then multiplication, addition, subtraction. So that is the order of bodmas. Yes, there are a lot of ads in between, you can skip them. Vaishnavi, there are so many games, there are so many number games. Click coaching with Nikhil Shubham. Please contact our iQuanta team. They will certainly guide you accordingly. Okay, so all of you know about this bodmas already. This we have done in our school time, but still most of the students attempt this calculation in the wrong way. They apply the order, they misapply the order of mathematical operations. So that's one of the difficulty. So let me ask you a question. Please answer this one fast. I'm just using plus minus only. So tell me 1 minus 2 plus 3. That's it. Please answer this question. What will be the value? What is your answer for this? Vaishnavi, not every game has a name, and if you are looking for names, so there are various variants of Sudoku by different names. Kakuro and Hitori. There are many names. You won't remember that. That's not required. I will tell you a lot of games. We shall play a lot of games. Don't worry. Okay, I'm getting different answers now. Some of you are saying 4 and some of you are saying 2. Minus 4 also. Arey Baba. 4, 2, minus 4. 3 different answers received so far. This is a simple question. For a simple question, there is going to be only one answer. But see in the comments, you can see yourself how many different answers different students are giving. This is a very tried and tested question. I have used this question in various classes. I'm teaching in a school as well right now. So I have asked this question to the students of as low as 3rd and 4th class standards and up to 12th class standard. And right now we are all graduates or pursuing our graduation. Some of you have passed out also. But still see so many different answers. See, don't misuse this bodmas. That is the only objective of asking this question. Don't misuse this bodmas. Although it is mentioned here that use addition first before subtraction, but it does not mean that to make a negative number as positive. This is not 2. It is negative 2. It is negative 2. ठीक है ना? This is negative 2. It is not positive 2. It is negative 2. So 1 minus 2. If we are doing addition first, this is negative 2 plus 3. So basically, addition subtraction can be done in any order. That's not a hard and fast rule. So, but what is important is that you don't miss the sign. This is not 2. It is negative 2. And this is positive 3. This is positive 1. Fine. So if you are doing addition first, so what you can do, you can add these two numbers, but this is not 2 plus 3. It is negative 2 plus 3. Can you tell me what is negative 2 plus 3? How much it will be? Verma ji, that is not correct. Minus 4 is not correct. This is negative 2 plus 3. What it would be? Negative 2 plus 3. Can you tell me? Negative 2 plus 3, which means basically 3 minus 2. So 3 minus 2 is 1. Isn't it? Yes, it is 1. It is positive 1. So this part is positive 1. And this 1 plus 1 gives you answer 2. A positive 2. That means this option. Okay, there could be another approach. Let's add the positive numbers first, then subtract the negative ones. That is also a way. Okay? Let's add the positive numbers first, then subtract the negative one. So if I'm doing that, so then in that case 1 and 3 both are positive numbers. So add these positive numbers. So 1 plus 3 is how much? It is 4. And 4 minus 2 gives you again 2. Isn't it? What else? You could have also done, let's do this 1 minus 2 first. So if I do 1 minus 2, how much it is? It is minus 1, isn't it? So 1 minus 2, if I'm doing in that order only, so this 1 minus 2, this is equal to minus 1. ठीक है ना? This is minus 1. And then we have plus 3. So this minus 1 plus 3. That gives you again plus 2. So basically answer is 2 only, but by misuse of this bodmas rule, we get different answers to such an easy question also. So don't do that, please. Is it okay? I hope it is clear. So my only objective was that don't do such silly mistakes. Most of the students, even after knowing the concept correctly, but while solving, while doing the calculations, do a lot of blunder. I'm seeing with the previous batch here also in iQuanta also, many students did commit this simple errors in calculation. Please avoid that. So the moment you will avoid the basic calculation errors, certainly you are a step forward. You are a step ahead in your preparation journey. ठीक है? Okay, so here are a few questions I'm having for you. Let's quickly answer them. Okay, there are 3 questions on your screen. Please answer them and don't do any mistake. Your time starts now. First one, 15. Many of you are saying, fine. Let me write it here also. So this becomes equal to, first we need to do multiplication. So 3 plus 12, which is 15. So ऐसा नहीं है कि first 3 plus 6 कर दो, that would be wrong. So first we need to do multiplication. So 6 into 2, 12. 3 plus 12 makes it 15. That's correct. Second one now. Dhananjay has solved all of them. Nice. Second काफी लोगों ने कर लिया है. Let me see. Good. Second one is 51. That's correct. So this time, first we need to solve this bracket, right? So 5 plus 4, this is 9. And there is no sign. This is also multiplication. This is multiplication. So it comes out to be, let me write. So this is 3 into 9 multiplied with 2 minus 3. So 3 into 9 is 27. 27 into 2, 54. 54 minus 3. 54 minus 3, that is 51. So this is the right answer for second. Third one. It's a fractional number now. Good. Some of you are writing in decimals, some of you are leaving it in fraction. Nice. So let's see. So first we need to open this round bracket. So that is 3 square minus 1. That comes out to be 9 minus 1, which is 8. So it is basically 2 into 8 minus 5. So that is in this square bracket, and which is being divided by 3, and we also have this 7 added to it. So now we need to simplify this round bracket. I have put this extra bracket here. It's not there. Leave it. Let me erase. Okay, so now this is 16 minus 5, which is 11, and 11 divided by 3. So it comes out to be 7 plus 11 by 3. So if you want to convert it into fractions, that can be done, or you can convert it in decimals also. 11 by 3, if I see it, is 3 and 2 by 3. This is 7 plus 3 and 2 by 3, which means 10 and 2 by 3, or 10.66 approximately. So this is your answer. And many of you have got correctly. Nice. Is it clear to everyone? So basically, in which order we need to apply the mathematical operations, we need to do that correctly, and then do our calculations also without any mistake. Okay, before I move further, let's play another number game. Right? Are you ready for that? Another number game? Simple game? Yes. I'm assuming that you are saying yes only. Yes, good. Okay, okay. We just played Make 6, right? This is an annual game. There are many mathematical institutes worldwide who play this game like this. Right now, this our year currently is 2024, right? 2024. Now, by using these 4 digits, 2, 0, 2 and 4, along with any of the mathematical operations that you know, can you make 1? Can you make 1? Please try. So annually they play this national game, game annually, and the target is to make all the numbers, make 1, make 2, make 3, up to make largest whatever is possible. And there is another thing here. We need to use these numbers 2024 in that order only. Their order should not be changed, and all the 4 numbers need to be used. We need to use all these 4 numbers in that order only, in this order only. Yes, what we can do is 2 plus 0 plus 2 divided by 4. Most of you are doing something like this only. Yes, we can use multiplication as well, but we have to use all the digits and in that order only. So multiplication is no choice. We need to add them only. Right. Good. Quickly make 2. Can we make 2? Calculations are everywhere, Tisha. You don't have direct questions to do this calculation, do that calculation, but calculations are required in every question. So this is just a warm-up exercise. How to make 2 now? Yes, excellent, Vaishnavi. We need to keep this order as well. Excellent, Vaishali. I can see 2 different answers so far here. P. Verma, you have done little bit hiccups between the positive and negative sign. Excellent. I have seen two different answers here. So one says this 2 is already there. So keep all of them 0. We can multiply all these together. So basically it is 2 plus 0 multiplied with 2 multiplied with 4. Right? This is one of the way. Or another way is 2 multiplied with 0 and after that minus 2 plus 4. So whatever way can we use? So we are going to get 2. Very nice. Can you make 3 also? Can you make 3 also? I think this should be difficult. Is it difficult or is okay? Three now, fast. And after that, directly I'm moving to 10. Here's any clues for 3. Vaishali has posted something 2 plus 0 by 2 minus 4. Okay, you missed to put the brackets. Fine, I understood. But again, Vaishali, you have done some mistake with signs, positive, negative signs. Please recheck and repost. And make use of brackets also. Astha, you have not kept the order. We want to keep the digits 2024 in that order only. Yes, Yatharth, you have put the brackets, but signs have been interchanged. Two divided by 2 is 1. 1 minus 4 is not 3. 1 minus 4 is minus 3. We want to keep it as plus 3, not minus 3, Vaishali. Sania has got a nice solution for 2. Good. You have used root. See, we need to use the sample negative sign before that. So if I'm keeping this as 2 plus 0 divided by 2, that will make it 1. So then 1 needs to be subtracted from 1. Na? So this part should be negative. So your answer which you are saying should be written like this. It is negative of 2 plus 0 divided by 2. That makes it 1. So plus 4. So negative 1 plus 4, that would be 3. Isn't it? Yes, Amit, that's correct. Excellent. AN has got a nice solution. Excellent, AN. So AN says 2 plus 0 divided by 2, that is 1. Now 1 plus square root of 4. 1 plus square root of 4, that is again 1 plus 2, that is 3. Nice. Excellent. Now quickly move to 10. How can you get this value 10? Tisha, calculator can be used, but for simple plus minus, simple with small numbers, you can do it on your own also, na? You are not allowed to carry calculator with you. You are provided with an on-screen calculator, which can be used for doing simple calculations. So the question is not about the calculation part. Question is about what to calculate, how to calculate. Calculating machine doesn't have its brain. Excellent, many different solutions I'm getting for 10. Nice. Aman Raj is saying 2 plus 0 plus 2 into 4. Let me write 2 plus 0 plus 2 into 4. Excellent. So this is 8 plus 2, 10. Very nice. Any other? Almost same thing many of you have written. Excellent. Hiransh has mentioned one solution. Good. Hiransh has mentioned a different solution. What we can do is, we can take it as 20. So 20 into 2, that is 40. And now which when divided by 4 will give you 10. Excellent, Hiransh. Yes, perfectly fine. Again, the objective was same. It was again a similar question as we did earlier. So objective was that only, that a question can be answered in various ways. The only requirement is that start thinking, start using your intelligence, right? So the moment you will start using your intelligence, you can find multiple ways to answer the same question. Now, whatever suits you, you can use that. Okay. Tisha, I have already answered your query. Okay, let's move further now. I'm erasing this part. I hope this is clear to everyone. So like that, there are various questions, as I think Vaishali was asking about different other number games. So that's how I recall that, because every year there are some international websites of mathematics which conduct this competition, that whoever gets the maximum number of things. So starting from make 1, 2, 3, 4, 5, 6, up to 2024. That is a target many people take. So you have to just use the basic mathematical operations and to reach up to this part. Anyway, so by the way, can you make 7 also here? Let me ask just one more. Can you make 7? Can you make 7 in this case? Tisha, what is the difficulty? Yes, you can use calculator, beta. Okay, Vaishali, it was you. It's fine, fine. Please try to make 7 also. Harsh, topic for today is numbers. We are discussing about the basics of numbers, not exactly the whole number system. We are just discussing the basics for numbers. How to make 7? Soumya, you are not allowed to use any other digit. Excellent, Karan, you have used factorial. Nice. You are not allowed to use any other digit. We are to just use these digits 2024, and preferably that also in the same order. In the same order. Excellent, AN. Good. Good. We have got a solution. So AN says, I hope you all of you know that whenever a number is raised to power 0, whenever a non-zero number is raised to power 0, the value becomes 1. So that's what AN has used. So AN writes that 2 power 0, that is 1, plus 2, that makes it 3, plus 4. So that comes out to be 7. Fine. Okay, let's move further now. So we have had enough of warm up. I hope all these numbers have synced in your brain cells. Astha, we are not allowed to use other digits. We are not allowed to use other digits. We are to only use these digits in that order only, along with any of the mathematical operations. Fine. So this one is a nice one, 2 power 0 plus 2 plus 4. So if you can think for something else, you can try. Okay, so I'm moving further now. So now we shall start with classification of numbers. See, there are various kinds of numbers. Can you tell me a type of numbers in the comments? What type of numbers you are familiar with, you are aware about? What type of numbers, what different varieties of numbers you are familiar with? Please write in comments. Yes, natural numbers, good. Anything else? Rational, irrational, real, odd, even, whole numbers. Yes, these are different terms. Excellent. Excellent. These are different terms. So basically, if you talk about the whole family of numbers, we call it, let's say, numbers only. And then there are two parts. One is, we can call it complex numbers also. So in complex numbers, we have two varieties basically. One is real, others are called imaginary numbers. So this imaginary numbers is not a part of our CAT syllabus, but those who have studied mathematics after 10th class, so you are familiar with this variety of numbers, imaginary numbers. So these numbers are those numbers which involve iota. The numbers which involve iota, which is nothing but square root of -1. So whenever a negative number comes inside the root, so that number becomes imaginary, and this square root of -1 is written as I. This I means it is called iota, IOTA. So this is called as iota and written as I. Fine. So they are called imaginary numbers. So sometimes we may get to use these numbers also in our CAT part, but mostly this is beyond the syllabus of CAT. Anyway, so mostly we are focused upon these real numbers. Now these real numbers are also divided into two categories. By the way, real number are those numbers which can be written on the number line exactly, which can be plotted on the real number plane exactly. Now these real numbers are of two categories. What are those two categories? One is called rational, others are called irrational. Okay. So what is the difference between rational and irrational? Can you tell me? What is the difference between rational and irrational? So rational number are those numbers which can be written in the form of P by Q. Which can be written in the form of P by Q, where P and Q both are integers. ठीक है, तो a number which can be written as a integer upon integer in this format, so that number is called a rational number. And of course, the numbers which cannot be written in this format, they are termed as irrational numbers. ठीक है ना? And also, if in decimal form we write rational numbers, so the rational numbers in their decimal form are of this form terminating. They terminates, that means after certain places of decimal they end, and or if they are not ending, if they are non-terminating, in that case they repeats, non-terminating and recurring. What is the meaning of recurring? That the repeats repeatedly, same pattern repeats. So if a rational number in its decimal form is non-terminating, that it does not end, then it continues. For example, I can take maybe 0.3333 like that. ठीक है ना? And terminating means let's say 0.25. That's it. Okay, so non-terminating and repeating, recurring. But in irrational numbers in decimal form, it is certainly non-terminating. This is non-terminating and non-recurring or non-repeating. That means irrational numbers when written in decimal format, so they are not going to terminate, they will continue, but they will not repeat as well. ठीक है ना? So for example, in your schools you have taken examples like that, maybe 0.2379 and so on. So there's no pattern of repetition. The digits will continue, but there is no pattern of repetition. Fine. Any other examples of irrational numbers? Yes, the root numbers are irrational numbers. For example, root 2, root 3, these are irrational numbers. Pi is an irrational number. E is an irrational number. Like that. There are many other examples could be. Fine. Okay, so we have briefly introduced about what are rational numbers and what are irrational numbers. Now, these rational numbers are further divided into two categories. They are further divided into two categories, and the categories are integers and fractions. Okay, they are divided into two categories, that is integers and fractions. So integers क्या होते हैं? So integers are those rational numbers whose denominator is 1 or minus 1. Fine. If you put this q equals to 1 or minus 1, so we are going to get an integer. ठीक है ना? So for example, if I take the example, so example would be 1, 2 and so on. 1, 2, these are different integers only. They could be negative, they could be positive. So these integers are divided into now this category of positive integers, which are called natural numbers. Natural numbers. And we have a number 0. So if 0 is included in natural numbers, that become a set of whole numbers, and there are negative integers as well. So this 1, 2, 3 and so on. So these are natural numbers. Fine. So if I include 0 also, that becomes a set of whole numbers. And there are negative integers as well, like minus 1, minus 2, minus 3 and so on. Okay? And fractions, you know, when denominator is not equal to 1 or minus 1, that rational number is a fraction itself. So this is basically a variety of numbers. So this was broadly the classification of numbers. I hope this is clear. Any doubts so far? Is it clear? Anything you want to ask, you can ask. I'm seeing the comments. So now there are various kinds of questions which we get from this, based on all these things. Be it real number, rational number, irrational, integers, fractions. Among integers also, natural numbers. See, most of the questions are based on these natural numbers, and further terms like odd number or even number or prime number or composite number, they are all categories of these natural numbers, or basically integers. So that we are going to discuss further. So that is broadly the distribution. And here also in rational numbers, sometimes we get a question like that. We need to convert this recurring number into fractional form. And these are the varieties of questions that we are going to discuss now. Okay, so let's move further now. So all these things we have discussed. So examples for real numbers. So all the numbers which we can have seen, they are real numbers. So basically they can be plotted on real number plane or number line. real number line exactly. Whether the number is rational or irrational, whatever number is this, whatever real number is there, it can be plotted on real number line exactly. We can always plot a number exactly on the number line. Now, rational numbers we have seen, right? So, rational number, for real number, the symbol to use in short is this capital R. For rational numbers, they are denoted by capital Q. For irrational numbers, there is no specific symbol. Sometimes Q dash is used. Otherwise, there is no specific symbol for that. So we have discussed the irrational numbers. So irrational numbers, I gave an example like the root numbers, root 2, root 3. It can be cube root of 2, like that. Basically all root value numbers which are not perfect powers. And also the logarithmic numbers, they also come into this category if it is not a perfect value. For example, log 2, log 3, like that. And this pi, e, all these are examples of irrational numbers. And rational numbers, what is the value of pi, by the way? Do you know what is the value of pi? Please write in comments. What is the value of pi? Do you know the value of pi? 3.14. But 3.14 to terminate ho gaya na? 3.14 is terminating in the decimal form. But we discussed that this irrational numbers are non-terminating and non-repeating. Okay, you are saying 22 by 7. So 22 by 7b is in the form of integer upon integer. Yes, it is not known accurately. So basically, these values which you have just told me as pi, so these are approximate values of pi. They are not exact values of pi. So I should replace this sign here with approximately equal to this. Approximately equal to this. Fine. So basically these examples 3.14, 22 by 7. So both of these are examples of rational number. So 3.14 is a rational number because it is terminating in its decimal form. Same way 22 by 7 is also a rational number because it is integer upon integer number, right? But pi is an example of irrational number. So these are just approximate values of pi. This is not exactly pi. Fine. So don't do this mistake. Always keep this in mind. Yes, this is approximate value. Fine. Okay. Let's move further. Also, we discussed about this thing, integers, fractions, and decimals. So among integers, we discussed the variety of natural numbers. We discussed about whole numbers and negative also. So for integers, the symbol is Z. Integers are denoted by a symbol capital Z. And again, for fractions, there is no specific symbol. Sometimes we use fraction, the symbol F for fractions. Fractions also has various categories. So sometimes fractions are divided into three broad categories. One is proper fraction, improper fraction, and mixed fraction. What do you mean by proper fraction? What do you mean by proper fraction? So proper fractions are those fractions in which numerator is smaller than denominator. Yani ki denominator is large number and numerator is smaller. For example, maybe 1 by 3, 1 by 2, and so on, 2 by 3. So these are all examples of proper fraction. Fine. Improper kisko bolenge? Improper is exactly reverse of that. That means when numerator is a larger number than denominator. For example, maybe this 3 by 2, 5 by 3, or 22 by 7 also. These are all improper fractions. Is it okay? This is improper fractions. Now, what is a mixed fraction? So, mixed fraction is a combination of integer part and fractional part. Integer part and a proper fraction part. So, basically all these improper fractions can be converted into integer part and its proper fraction part. See, 3 by 2, it is more than 1, isn't it? So 1 is the largest integer contained in this. So if I write, if I separate the 1, so what is the remaining part here? 1 by 2. So this 3 by 2 can be written as 1 and 1 by 2. So that is known as mixed fraction. It contains the integer part as well as the proper fraction part. ठीक है ना? Yes, exactly. So similarly, 5 by 3, if I convert it, it is going to be how much? This is, again, 1 is the integral part and 2 by 3 is the fractional part. So this is 1 and 2 by 3. Same with 22 by 7. So it comes out to be 3 and 1 by 7. I hope you are getting it. How I'm getting this 3? Yes, you can divide 22 by 7. So basically, you can understand it like this. Let's say we have 22 laddus. Okay? We have 22 laddus and I need to make packets where each packet contains 7 laddus. So 7 laddu wale 3 packets ban jayenge na, right? There are 3 complete packets. Now 1 laddu is remaining. So 1 by 7. So 3 and 1 by 7. So that's how these are all mixed fractions. Is it okay so far? Is it clear? Yes or no? Okay, so before I move further, I would like to ask you a small question. Please answer this fast. I need to do the simple calculation. 7 3 by 4 plus 12 1 by 4. Please answer fast. Please answer fast. Vaishali says 80. Nahi bhai. Yes, 20 is correct. Aman, Astha, Vaishnavi. Vaishnavi also say 80. No bhai, no Vaishnavi. Vaishnavi, Vaishali दोनों ने same गलती की है. 20 is correct. Nice. Can you tell me how have you done it? Many of you have done it correctly. 20 is the right answer. But how have you done it? Can you briefly tell that, please? Yes, 20 is correct. 80 divided by 4. That's true, Vaishnavi. Yashin. Have you converted this mixed fraction into improper and then to calcium and salt? Is that the way? Have you converted them into improper first? Please answer. Yes, you are doing that only. Yes, Kirti, this is a recorded session. It will be available on this YouTube channel only. Don't worry for that. Yes, you have done that. But I can see some other answers as well. Yes, good one, Sania. Yes, that's what I was looking for. Aman, yes, that's good. Nice. Okay, see, both ways I can see here. See, what is a normal trend? What do people do? 4 into 7, that is 28. 28 plus 3, that is 31. So it comes out to be 31 by 4, isn't it? That is the improper fraction for this. Similarly, 4 into 12, that is 48 plus 1, that is 49. That makes it 49 by 4. That is the improper fraction for this. Now, because 4 is the denominator, same denominator, so we can directly take this 4 as the LCM, or basically we can directly add these numerators. 31 plus 49 upon 4. So 31 plus 49 comes out to be 80. So 80 by 4 is 20. So this is one of the ways. This is not wrong. It's fine. It's okay. But it is not required. It is not required. Yes, exactly. And that is perfectly nice thing. And that should have been done. See, some of you have done that in comments. I'm writing it here. See, we need to acknowledge this. We need to understand this, that when we are saying this 7 3 by 4, it is basically 7 plus 3 by 4. Yes or no? It is 7 plus 3 by 4. It is not multiplication. It is 3 by 4 more than 7. Similarly, this is 12 plus 1 by 4. And we are adding these two numbers. So we can directly see this is 7 and this is 12. So 7 and 12, they are to be added. That makes it 19, isn't it? So this is 19. And further, we have these two fractions which are to be added, 3 by 4 and 1 by 4, which can be done very easily. So whatever the part you were doing here, so you should do the same thing with the smaller numbers. There was no need of converting it into improper fractions first. So 3 by 4 plus 1 by 4 makes it 1 simply, and the answer comes out to be 20. So that is certainly an easier one. And for this part, you don't even need to write. For this part, you may have to write, but यहाँ पर लिखने की भी ज़रूरत नहीं है. Is it fine? Yes, many of you did same thing, and I'm really very happy for that. Good. Okay, please answer one more fast. If I ask you, 197 1 by 7 plus 202 6 by 7. Answer fast. Answer fast. Excellent, Astha. Did you need to write anything for this? Certainly not. Excellent. AN, Swapnil, Sania. Good. So I hope the thing which I was just discussing is clear to everyone. See, if you had used the same earlier method of converting this number into improper fraction first, certainly this is going to be a long calculation, and for that purpose you have to make use of calculators, which is available. But that's not required. Even after using calculator, it is going to take long time. But if you apply a little bit of intelligence, then you can very easily see 197 plus 202, they can be added separately, and 1 by 7 plus 6 by 7 is going to make 1 only, right? Then it becomes very simple. It is simply 400. Nothing to write. Before you type anything on calculator, before that you will get the answer. It is 400. Is it not? Yes. Good. Is it clear to everyone? Okay. Okay, let's move on now. So next we have decimals. We talked about decimals. So some numbers are there which end in decimal, which terminates, and some are non-terminating. Terminating decimals, and other than that we have non-terminating and recurring, and the other part is non-terminating and non-recurring. Okay, I'm erasing it. So non-terminating and recurring, and the last one is non-terminating and non-recurring. So these first two varieties are the parts of rational numbers, and this is irrational numbers. So now terminating is obvious, it's fine, it is ending after decimal, and this one is non-terminating but non-recurring also. There is no repetition of any digits, any pattern of the digits after decimal, so that is an irrational number. But this variety is an important part. This is an important part, and as I said earlier also, we find some questions where we need to convert such decimal numbers into the rational format, that is integer upon integer format. For example, can you tell me the value of 0.3333? It is repeating. Can you convert it into fractions? What it comes about? 0.3333 and so on. It is repeating. So what is its value in fractions, or basically integer upon integer format? Ten by three is not correct, आस्था. अरे 10 by 3 तो 3 से ज्यादा हो जाएगा ना. It is 0.33 I'm mentioning. Vaishnavi, no, again you are giving same answer. Yes, it is 1 by 3. 1 by 3 is right answer. Dhruv, 3 by 9 is also right, but whenever answering, we should give the fraction in simplest form. So 1 by 3 would be the right answer. ठीक है ना? Nice. Now, this was a simple one. All of you can do it easily. But how to do it, let's check now. Let's check now. So a question was, we are having a number 0.333 and so on. We need to convert this number into fractions. So let's call this number x. And first see one more thing. When we are having such number, which is repeating after decimal, which is having a repeating block of digits, so this is called recurring decimal, right? Recurring decimal. Let me write. This is called recurring decimal, because it is reoccurring. It is occurring again and again. So the whatever group of digits is repeating, so we put a bar over that. So it can also be written like this, 0.3 bar. So now this bar basically here means this 3 is going to appear bar, right? This 3 is going to appear bar. So that's how we call it 0.3333 and so on. Now how to simplify this? So all of you are done in your schools. So first you multiply both sides by 10. So if I multiply by 10, so we are going to get 10x. The value is going to be how much? This 1 3 will come before decimal. So it becomes 3.3 bar. Isn't it? This is 3.3 bar. Or I can also say that is 3 plus 0.3 bar. This 0.3 bar was nothing but x. So basically it is 3 plus x. And now subtracting this x from left hand side, I am going to get 9x equals 3, which means this x is equal to 3 by 9, and in simplified form it comes out to be 1 by 3. So that is our answer. ठीक है ना? Okay, quickly answer one more. If I am having a number like 0.272727, so please convert it into fractions fast. Yes, answer please. Dhruv, I said you please convert it into simplest form. Yes, Aditi, that is correct. Sania, good. Yash Singh, Amit. Yashasvi, see, all the steps are mentioned here. Let's see it again. Let's see it again here. So this 27, 27, 27, you can see this, the group of 27, it is repeating after decimal. So we can write it as 0.27 and this 27 is under the bar. Fine. So we are assuming this to be our x. So how to solve it further now? So because in this repeating block, we are having two digits. So we need to multiply with 100 both sides so that this 27 will come before the decimal, isn't it? So it is going to become 100x equals this. From here you can see, or wherever, it is 27.27 bar now. This is 27.27 bar. Fine. So just separating out as I did earlier. So this is equal to 27 plus 0.27 bar. I've just separated the decimal part and the integral part. And this 0.27 bar was our x only. So this is 27 plus x. Now simply subtracting x from both sides, we will get 99x equals this 27. And we are done. X comes out to be 27 by 99, which can be further reduced because 9 is the common factor. So 9 3s are 27 and 9 11s are 99. So 3 by 11 is the right answer. Okay? I hope it is clear. And in many exams, you get questions like this where we need to convert this type of recurring decimals into fractions. Maybe it is a direct question, or sometimes we need to compare the numbers, or sometimes in some long calculation, many of such numbers are there. So can we do it in some quicker method? Yes, there is a quicker method for that. Now let's see what it is. So the method is, you can see in denominator, always you are going to get 9 or 99 like that, right? Sometimes it may be followed by 0 as well. It is before simplification. On simplification, it can get cancelled like in these two cases. But before getting cancelled out, you will always find that denominator contains nines, or any number of nines, some number of nines followed by 0 sometimes. So what that happens, let's see now. So I'm taking 2-3 examples. Let's say my number is 20.24 and say 24 is under the bar. It is the repeating block, and let's say number is another number 20.24. Only 4 is there in the repeating block. That could be one of the cases, and I think that these two are sufficient. So what is going to happen is, either our repeating block starts just after decimal, or there may be some digits before the repeating block starts. So these are two examples. These are the two varieties of answer we are going to get. Now see how we can answer these questions faster, which includes all these steps. We don't need to do all these steps separately. How we can do them directly? See, what is the method now? So we need to write our answer in a fractional form, which is having some numerator and some denominator, isn't it? Fine. Now the denominator will always contains some nines followed by some zeros. So how many nines? Listen carefully now. The denominator will be having that many number of nines, which is the number of digits in the repeating block. I repeat, जितने इस repeating block में digits हैं, as you can see here, there are 2 digits in this repeating block, right? This 24 will continue every time. So this 24, that is 2 digits are there. So the denominator will have exactly 2 nines. So it is 2 nines. If in this denominator I see there is only 1 digit in the repeating block, so there will be only 1 9 in the denominator. I hope this point is clear. Okay? All these steps I'm just discussing here, they have been obtained from these simplifications only, but directly we can use them like this. So there are 2 digits in the repeating block, so 99. There is only 1 digit in the repeating block, so 9. Now these nines will be followed by zeros if there is a gap between the decimal and the repeating block. I repeat, अगर decimal और इस repeating block के बीच में कुछ gap है, if there are certain number of digits between them, in that case there will be as many zeros as is the number of digits in between. See, in this case there are no extra digits in between, so there is no zero here. But in this case you can see there is one extra digit, it is 2, right? This 2 is the extra digit which is after the decimal but before the repeating block. So there will be 1 0 after this 9 here. Is it okay? That was about the decimal part, this denominator part of this fractional numbers. Okay? This I hope this denominator part is clear to everyone. Fine. Now let's quickly move to the numerator part. So for numerator part, it is very easy now. So numerator part, what we need to do? Remove the bar, remove the decimal. Remove the bar, remove the decimal. So write the complete number here, 2024. Here also 2024. Fine. And now we need to subtract something from this. We need to subtract something from this. So what we need to subtract? We need to subtract that part of this 2024 which was not the part of repeating block, जो repeating block में नहीं था. So that is 20 in this case. From this 2024, this 24 was the part of repeating block. 20 was not there, so 20 needs to be subtracted. In this case, out of this 2024, only 4 was the part of the repeating block. Remaining 202 was not part of that. So I need to subtract 202 here. Now that's it. On simplifying this, you can get your final answer. Okay? So that's it. That's it. So we just need to make sure of these two methods. Only these two are going to be the cases, whether there is no gap between the decimal and the repeating block, or there could be any gap between the decimal and the repeating block. So denominator will be having only 9s. How many 9s? As many 9s as are the number of digits in the repeating block. Here there were 2 digits, so 2 9s. Only 1 digit, so 1 9. Followed by zeros. How many zeros? So as many zeros as there is a gap between the decimal and the repeating block. There is no gap, so no zeros. There is a gap of 1 digit, so 1 0. That was numerator. Now denominator, remove the bar, remove decimal, so 2024 minus, we have to subtract that part of this number which was not under the bar, जो bar में नहीं था, जो repeating block में नहीं था. So this 24 was under the repeating block here, so 20 needs to be subtracted. Here in this case only 4 was under repeating block, so 202 needs to be subtracted, and that will give us our final answer. Fine. So I hope all these steps are clear to everyone. I have repeated it. Now let's apply it. So that will make it firm. Fine. Let's apply it. You can simplify it here also. If I simplify, this is going to be how much? 20 if you will subtract. This is 2004 divided by 99. Can you further simplify it? Yes. 3 is the common factor I can see here. So if you divide it by 3, it will be 3 6 are 18. Again 2 remaining, 3 6 are 18. 2 remaining, 3 8 are 24 upon 3 3 are 9. 3 3 are 9. So 668 by 33. Same way in this case, a value would be by subtracting 2, it is 22, and 1822 upon 90. Is there anything common here? Yes, this time 2 is the only common factor. So if you divide it by 2, it comes out to be 911 by 45. So this is the final answer. Is that okay? Good. Yes, 668 by 33 for the first one, and for the second one it is 911 by 45. Yes, good. Let's quickly move to solve a few questions. Yes, these are the few questions. Please answer them fast. Please answer them fast. Don't do this mistake. This is question number 1, question number 2, Question number 3, question number 4. These circled numbers are not the part of the number. ठीक है ना? This first one is 0.37. Let me write. This is 0.37 bar. The second one is 0.127 bar. This 127 is repeating here. In this third one, it is 0.1234 and only 4 is under the bar. And here it is 2.5, then 3636. So this 36 is under the bar. Now please answer them. Excellent. First one you have answered correctly. Very nice. Wonderful. Second one is also correct. Good, Aman Raj and Vaishali. Just saying you missed to forget, you forgot to subtract the non-repeating part in the third question. Please check your answer. For this third question, see the denominator has to have 19 followed by 3 zeros. That's perfectly fine. In the numerator, it should be 1234 minus 123, isn't it? Which will give you answer as 1111 upon 9000. If there's some common factor that can be cancelled out, by the there is nothing. And the last one is going to be, in the denominator there will be 2 9s followed by 1 0, and in numerator it is 2536 minus 25, isn't it? And if you subtract, you are going to get this 2511 upon 990. Now 9 is the common factor. 9 is the common factor here that you can cancel out. Henna? 9 is the common factor here. So if you cancel out with 9, so what will you get? 9 2s are 18. 7, so 9 7s are 63 and 9 9s are 81 upon 110. So this will be the answer. Yes, 279 upon 110. Good. Hiransh, for which question you have answered this? 101 upon 909. P. Verma, how did you got this 2483 upon 990? If you subtract this 25 here, you are going to get 2511, isn't it? Nice. Okay, I hope it is clear to everyone. Fine. Okay. Shall we move ahead? आगे चलें. Yes, there was a mistake. Fine. Okay, let's move further now. So, we discussed about various things. Now, let's come to the next variety of numbers, which are called prime numbers. Prime numbers. What do you know by prime numbers? Can you tell me what is the smallest prime number? So basically, prime numbers are those numbers which have exactly two divisors, or which have exactly two factors, or in other words, which are divisible by exactly two natural numbers. ठीक है ना? Which are divisible by exactly two natural numbers, two positive integers. They are called prime numbers. And 2 is certainly the smallest prime number. Achha, what about 1? Is 1 a prime number or not? Is 1 a prime number or not? 1 किस-किस से divisible है? Let's check. 1 which natural number divides 1 completely? Only 1. It is not a prime number. Okay, this is not a prime number. Let me write on the other side. So 1 is having only 1 as a divisor, so 1 is not a prime number. 1 is not a prime number. Harsh, no need to panic. Are? 1 is not a prime number. Why? Because it has only one natural number divisor. It is divisible by only one natural number. What about 2? 2 किस-किस से divisible है? Harsh, you only tell me. I'm waiting for your answer. 2 किस-किस से divisible है? It is divisible by 1 as well as 2. That's it. So it is divisible by exactly two natural numbers. So yes, it is a prime number. What about 3? 3 is also divisible by exactly two natural numbers, 1 and 3. So this is also a prime number. What about 4? 4 is divisible by exactly 3 natural numbers. What are they? 1, 2, and 4. Right? So this is not a prime number. What about 5? By the way, this 4 is a special number. 4 is the smallest number which is having exactly 3 factors. Right? 4 is the smallest number which is divisible by exactly 3 natural numbers, 3 different natural numbers. So what about 5? It's 1 and 5 only. So this is also a prime number. 6, it is divisible by 1 as well as 2 as well as 3 as well as 6. So this is not a prime number. ठीक है ना? So now I hope you have understood what we are doing. Harsh, don't worry. See, for examination, there is always a little bit of what you call examination fever, examination phobia, right? But we need to take it. Yes, we need to take it and take it boldly. So just prepare yourself as much as possible and then let's face it. ठीक है ना? There is no difficulty. And the biggest good point here is that a test is common for everyone, right? So whoever is a better person, whoever performs nicely will certainly perform better. So that's what we are to do. We are to not compete with others. I just need to compete with myself. I need to become a better person and perform better. That's it. So no need to worry about little bit of phobia, little bit of fever is always there, and that's good. Little bit of anxiety will be there and it's good. Take it in a healthy way. Okay, so I hope it is clear now. So when a number has exactly two natural number divisor, this number is having two divisors, it is a prime number. This also is having two divisors, this is a prime number. This one was having 3, it is not. So this is called composite number. This was having 2, so this is a prime number. This was having 4, so this is not a prime number. This was having only 1. So 1 is the only number which is having exactly one divisor. So this is neither prime nor composite. ये prime भी नहीं है and composite भी नहीं है. Fine. And those who are having exactly 2 divisors, they are called prime. This is prime. This is prime. This is prime. Fine. And those who are having more than 2 positive integral divisors or natural number divisors, they are called composite numbers, like this one. This is the composite number. This is also a composite number. Fine. I hope this is clear. Good. Yes, 7 is also a prime number. Nice. Okay. Now the next thing is that, can you quickly write and calculate and tell me the answer that how many prime numbers are there which are less than 100? How many prime numbers are there that are less than 100? Please calculate. We need to write and quickly you need to see how many are there which are less than 100. Let's write it together, I guess. Let's write it together. Few we have already found out. We have seen 2, we have seen 3, we have seen 5 and 7 also, one of you mentioned. So let's write it here only. So 2, 3, 5, 7. See, 2 is the only even prime number, because after that everyone is going to be odd number, right? Many of you already know the answer, 25, that's the correct answer. So that's why I'm writing it together. Let's write it here and become a bit familiar with them. So 2 is the only even prime number, all other are going to be odd. And these are the numbers, prime numbers which are less than 10. ठीक है ना? आगे बढ़ते हैं. So after that we are having 11, 13. What after that? 15 is not prime, because I'm looking only for odd numbers now. So 15 is not there, but 17 will be there, 19 will be there. So these are next 4 prime numbers. After that, 21 is not prime, 23 is, right? 25 is divisible by 5 now. 27 is also not prime, so 29 is the next prime number. So till 30 you can see, till 30 we have these 4 plus 4, 8 and 2, total 10 prime numbers, right? Till 30 there are 10 prime numbers. Let's proceed further. So after 29, in the next tuplet now we are having 31, which is a prime number. 33 is not, it is divisible by 3. So 35 is also not prime, 37 is prime, 39 is divisible by 3, that's not. आगे चलते हैं, 41, 43 and 47 they are prime. And ठीक है, तो this is till 50. So till 50 we have 5 more, right? So till 50 we have 5 more, so total makes it 15 prime numbers in all, right? Till 50 we have total 15 prime numbers. Let's proceed further now. After 47 we have now 51 is not prime, 53 is prime, 55, 57 are not, 59 is prime, then 61, 63 and 67, then 71, 73 and 79 as well. After that we have 83, not 85, not 87, but 89 is prime. After that we have finally 93, 95, 97. That's it. So till 100 you can see 2 and 3, 5 and 3, 8. Is there some mistake? 2 and 3, 5. Oh, 63 is not prime, na? There's one mistake here. The 63 is not prime. 63 is divisible by 3. 63 was not prime. So 2 and 2, 4 and 3, 7 and 3, 10. So there are 10 more. So till 100, you can see this 10 more. So total 25 prime numbers are there. Fine. So there is no fixed pattern of prime numbers. So till first 50, there are only 15. But in the next 50, we have just 10 more, right? So till 100, total 25 prime numbers are there. And if you ask for the further prime numbers, that means from 101 to 200, if we check, so there are only 21 prime numbers more. So in this first 125 prime numbers were there, but in the next 100 numbers, only 21 prime numbers are there. So there is no fixed pattern of the number of prime numbers. It keeps on changing. Here also we are saying they are decreasing. So their rarity is continuing. They are becoming more and more rare. Anyhow, so we should be familiar with at least this few basic, the initial, the smaller prime numbers. Okay? And we have already seen that there is only one even prime number, others are going to be odd certainly. I hope these basic things are clear. Now let's answer a few questions. Here's the first one. This we have already solved. So how many prime numbers are there which are less than 100? So this is 25. Okay? Now this is a question for you. Please answer this. Please answer this. Question is, for how many prime numbers this expression p cube minus 1 is also a prime number? Astha says 2, Sania says 1, P Verma says 2, Yash Singh says more than 3. Which option, A, B, C or D? Vaishali, Swapnil say 1, that is option 1, A. Aman also says option A. Amigo says 2. Which option? Vaishnavi, you tell me, is 0 a prime number? No, prime number is a category of natural numbers. And by the way, 0 is divisible by every natural number. 0 is divisible by every natural number. So 0 cannot be called as prime number. Yes, it may appear to be D as Yash Singh mentioned, because ऐसा लगता है कि हो सकता है बहुत सारे numbers होंगे. Let's check out. We have to see for how many prime numbers P. So P is a prime number basically, right? P is a prime number. So what is the smallest prime number? It's 2. It's not 0. Who was saying 0? So 0 की तो बात ही नहीं है. So 2 is the smallest prime number. So let's check for that. So if I put this P equals to 2, so 2 cube minus 1. What is the value? 8 minus 1, that is 7. 8 minus 1, that is 7, which is also a prime number. Fine. So this will work. So P equals 2 will work. Fine. Let's check the next case. What is the next prime number after 2? What is the next prime number after 2? Yashashvi now says option B. Okay. What is the next prime number after 2? See, the question is how many prime numbers. It is not asking the value of P. It is asking how many. We need to find out how many are there. So if next prime number after 2 is 3, isn't it? So if I put the value of P as 3, so it becomes 3 cube minus 1. Now 3 cube is 27. 27 minus 1 is 26. 27 minus 1 is 26. Is 26 as a prime number? Not possible. It is an even number. It is divisible by 2. So this cannot be a prime number. This is not a prime number. Should we check further also? Yes, excellent, Aman. Good. So we don't need to check further, because after 2, all prime numbers are going to be odd numbers. So odd number ka cube karenge, so that will always result in an odd number, right? So that will always result in odd number, and odd number में से 1 subtract करोगे, so what will be the result? It will be an even number which cannot be a prime number. ठीक है ना? So there is no need to check further. So question was, for how many prime numbers P this number is also a prime? Now you tell me the answer. What is the correct answer? What is the correct option? A, B, C or D? What is the correct option? Yes, of course, A is the correct option. P वर्मा जी अभी भी B बोल रहे हो भाई, इसने P की वैल्यू नहीं पूछी है. It is asking about for how many prime numbers P. That means how many values are possible for P. P can take only one value, that is 2. ठीक है ना? So option A is the correct answer. Fine, let's quickly move further now. So we have already talked about composite numbers. So those numbers which are having more than 2 factors or 2 positive integral factors. So the numbers which have more than 2 positive integral factors, they are known as composite numbers. ठीक है? So, can you answer this question? How many composite numbers less than 100 are there? Please answer fast. How many composite numbers less than 100 are there? Okay, I've got one answer from Sania. Swapnil, Karan, Astha, Aditi. And it's a good thing everyone is giving the same answer. तो या तो सारे गलत बोल रहे होंगे या सब सही बोल रहे हैं, बट खुशी की बात है all of you are answering correctly. Very nice. So 74 is the right answer. How? Because you are talking of numbers less than 100. So till 100 if I count, there are total 100 numbers, out of which the prime numbers are to be left, which were 25. I think answer should be 73. Answer should be 73. Right? Because I am talking about less than 100 here. So less than 100, I need to leave 100 also, na? So from 100, I need to leave 25 prime numbers. I need to leave one number which is 100 itself. I need to leave one number which is 1. Isn't it? So the answer comes out to be 73. Is it okay? Yes, Aman, you are right. 74 are composite till 100, but question was asking less than 100. That's why we need to leave 100 as well. अरे ये तो खेल खेल में अच्छा सवाल बन गया नहीं? Okay. So I hope this part is clear to you. So because it was talking about less than 100, so we need to leave 100 as well. So the important point was that till 100 there are 25 prime numbers. The information which we just calculated earlier, it must be with us. Otherwise it is a lengthy question. Yes, question was asking about less than 100. That's why we have left 100. Otherwise, 74 was fine. I also agreed initially, but when I saw this, it is less than 100. Then I have found this. I need to leave this 100 as well. And also we need to leave 1. Don't forget this 1 also. ठीक है ना? So 1 is neither prime nor composite, and that's it. So that's how the answer. Okay. Similarly, now next, even number and odd number. Which numbers are said to be even? Although we have used these even numbers and odd numbers, which numbers are said to be even? So the numbers which are divisible by 2. The numbers which are divisible by 2, they are known as even numbers. ठीक है ना? Welcome Shivanshu. Yes, with your profile, certainly you can go ahead. So even numbers are the numbers which are divisible by 2, or if we write them in mathematical format, so we will say the numbers of the form 2n, which are multiples of 2, isn't it? And odd numbers are there, those numbers which are not divisible by 2. Not divisible by 2. So if a number is not divisible by 2, it means it will leave some remainder when divided by 2. Can you tell me a number when divided by 2, but it is not divisible completely? So what will be the remainder obtained? What will be the remainder obtained? So remainder will be 1 always, right? When you divide a number by 2, either it is going to be divisible, that means remainder is 0, or the remainder is going to be 1. So the odd numbers are those numbers which are not divisible by 2, which means which will be remainder 1. So that means the number will be of the form 2n plus 1. ठीक है ना? That's it. Yes, we are not writing the number in decimal, we are finding the remainder if there is any. So the number which is completely divisible by 2, they are called even, and which leave a remainder of 1 when divided by 2, they are called odd numbers. Fine. So before I move further, I have again a quick question for all of you. Can you tell me, let's say I'm writing it here. You have to tell me whether it is even or odd. So a number n, you have to tell me whether it is even or odd. It is given that n is divisible by 3. Please tell me whether n is even or odd. You have to tell me whether it is even or odd. Even or odd. It is given that n is divisible by 3. Is it even or odd? Yes, quickly please. Vaishnavi Aman says it can be both. Good. Very nice. आप सब तो intelligent लोग हैं. See, immediately many students answer whenever they hear it is divisible by 3, immediately they say odd. But odd या even क्या है? We have just talked about कि whether number is divisible by 2, then it becomes even. Otherwise, it is known as odd. So divisible by any other number does not specify whether number is even or odd. If it is divisible by 3, it can be even. For example, 6. It can be odd also, maybe 9. ठीक है ना? So divisible by 3 say it can be either of the two. We are not sure about that. So only we can be fixed about a number, we can be confirmed about a number whether it is even or odd only if we get to know about this divisibility by 2. So if the number is divisible by 2 or not divisible by 2, only then we can say it is even or odd. Otherwise not. ठीक है ना? Arey Aman, these things, simple things are used. CAT doesn't ask directly this question. CAT doesn't ask directly this question. But these basic concepts are used in answering many questions. And students answer these things wrongly. I've seen this a number of times. Okay, let's quickly move further now. There is a small term known as co-prime numbers. So co-prime is a term for those two numbers which do not have any common factor. I repeat, See, prime number we saw that which are prime, which are not divisible by anything else other than two numbers. So co-prime are those numbers, such two numbers which do not have any common factor. Basically, it means correspondingly prime. Correspondingly prime. Yeah, sometimes the term used is relatively prime. Relatively prime. So the numbers need not to be prime numbers, but the two numbers, or maybe more than two also, which do not have any common factor. For example, if I ask you, please tell me 2 and 3, can this pair of numbers be called as co-prime numbers? Are 2, 3, can they be called as common co-prime numbers? Here, please tell me. 2, 3. Yes, Vaishali, you are right. There are many different questions like that. So 2, 3. Can they be called co-prime numbers? Yes or no? Yes, they are. Because they do not have any common factor. Because they do not have any common factor. ठीक है ना? Don't worry, Yash Singh. Our normally live sessions, these are some of the free sessions basically. There are some basic sessions, pre-sessions in a sort of. In YouTube, this is a difficulty. You will get ads in between. But don't worry, this problem will not be there. So are these co-prime numbers? Yes, because they do not have any common factor. Or in other words, we can say their highest common factor is 1. HCF of 2 and 3 is 1 because their highest common factor is 1. So they are co-prime numbers. Fine, they do not have anything common. Okay, tell me now, what about 4 and 3? Can they be called as co-prime numbers? Yes or no? Yes, because they do not also have any common factor. Right? 4 और 3 में भी 1 के अलावा कोई common factor नहीं है. So they are also co-prime numbers. What about 4 and 9? Are they co-prime numbers? 4 and 9, are they co-prime numbers? See, now none of them is a prime number. 4 is also a composite number. It's square number. It's square of 2. Same way 9 is also square of 3. It's also a composite number. But yes, again, they do not have any common factor greater than 1. Their still highest common factor is 1. So these are also an example for co-prime numbers. समझ में आ गई बात ये? So what is the meaning of co-prime numbers? That was the important point here. So the co-prime numbers are those numbers which do not have anything common. Whether the numbers are prime or not, that does not hamper being a co-prime number. Fine. So individually a single number cannot be co-prime numbers. So co-prime numbers means when you are having two or more than two numbers together. So we are checking whether they are having any common factor together or not. If their highest common factor is 1, so if HCF of P and Q is equal to 1, then we say that P, Q are co-prime to each other. Fine. So that is the key learning from here. So when two numbers have highest common factor 1, then they are said to be co-prime to each other. Is it okay? Exactly, Aman. That's true. For the two numbers to be co-prime, it is not compulsory for the two numbers to be prime. So co-prime का मतलब वो नहीं है. Co-prime का मतलब है common factor 1. Exactly. Highest common factor 1. Yes, 1 also can be counted here. Excellent. So if I say, are 1 and 100 co-prime to each other? Are 1 and 100 co-prime to each other? Yes. 1 and 100 are also co-prime to each other. Good. Now let's solve this answer. This is the last question for the day. Our time is almost up. Now this is the last question. Please answer this one fast. I think we have solved it already. We have solved this question already. Please answer. Yes, Yash Singh, that's correct. 11 and 13 are co-prime to each other. Hiransh, I have already told you for the book part, you can go for the iQuanta books. And regarding working on basics, that is certainly required. And for that purpose, I will certainly recommend using NCERT books for classes from classes 6 to 10th at least. NCERT 6th to 10th. That is must. That is highly beneficial to work on your basics, and that we are using in our non-engineering videos also. So if you have joined our product, you can certainly take the benefit of that. If not, then it's up to you. But NCERT books would be certainly beneficial other than your iQuanta books. Okay, quickly answer this question. This is the last one for the day. $126 is not correct, Vaishali. Yes, Aman, Vaishnavi, 14 is right. Good. See, we had solved it already, you know. This 0.27 bar, this is P by Q. If you convert it, it comes out to be 27 by 99. So don't just add 27 and 99. I think somebody did that only, na? Vaishali ne yahi kiya tha. So, but these P and Q are not co-prime, na? It is mentioned P and Q are co-prime. So you need to simplify it first. So 9 is the common factor. So 9 3s are 27 and 9 11s are 99. So answer would be 3 plus 11. So 14 is the right answer. So P plus Q is 3 plus 11, that is 14. So this is the right answer. Okay, so we shall end it here. Thank you everyone. Hiransh, that's very nice. So please, I will suggest that you please continue with those non-engineering videos. And wherever there is any difficulty in understanding any concept, certainly ask questions. But practice is the only key. See, books also can give you the correct concepts. The videos can also give you correct concepts. But how are you applying them in solving questions? That's up to you. And that you can better just by practice. ठीक है ना? So please continue practicing, and wherever you face difficulties, certainly seek help. Thank you everyone. Thank you. So I shall take your leave now. If there's any question, any query, any comment, I'm still here for 1 or 2 more minutes. I hope the session must have added some value to you. And if it is, then certainly I'm really grateful for that. Excellent, Karan. Thank you. I said that was my only objective, that if I can lighten up the flame within you, little bit flame, little bit spark, so that spark will be certainly beneficial. Thanks for your association. Thanks for your constant attempts, regularity. Nice. Yes, it is certainly possible in 4 months, Aman. Why not? Thanks, Vaishali. Okay, again, thank you very much. So I shall take your leave now. I'm exiting the live stream. Classes daily hongi. Karan, for that purpose, you need to contact our iQuanta team. So regarding scheduling, regarding books, or regarding the various course options. So please contact our iQuanta team. They will certainly help you. Rishant, is there any trick to convert small decimal values to fraction in seconds? Practice. Government job versus MBA future. It's your choice. People are satisfied in government jobs, in MBA as well. And you can find unsatisfied people also in both fields. So it depends upon your choice, your priorities, isn't it? Never be demotivated, Aman. It's okay. There are always ups and downs in life. No problem. Go ahead. Whenever you fall down, get up and go ahead. So that should be our motto. That should be our way of living. There will always be hiccup in life. Okay, so taking your leave now. Thank you very much.